Hello, dear viewers. Welcome to the Physics Master revision session number 3. So this one I'm going to call it 3A, then I'll have 3B, 3C and all that. So each session will last for around 15 minutes. I'm still looking at the past paper questions of grade 12 bilingual system in Oman. So specifically compiled questions from one topic, and that is electricity. As I always say, read to understand and stand out. And please don't make this day a boring day, because a day without solving a physics problem is a boring day. And of course, we can't imagine life without physics. So let's do this. Question number 15. Okay, from my pamphlet. Which of the following graphs shows the relationship between the resistance of pure metals R with temperature? So the resistance of pure metals with temperature. Now, what happens to the resistance of a pure metal when you increase its temperature? Of course, the resistance always increase also. So our graph, we expect some increase in resistance as we increase the temperature. You can look at these graphs. If you analyze the first one, then what is happening? We have some increase in temperature, but there is no change in resistance. If the resistance at this point is 10 ohms, then it is just 10 ohms. Look at this one. So these are no. Look at this one. Here, as we increase the temperature, it's like the resistance is decreasing. Of course, it's kind of an exponential relationship, because at first it's decreasing very fast, then it's slowing down. We can't go with that. If you look at this one, we have the same thing. As you increase the temperature, we have the resistance going down. So this is what we will go with here. Of course, the resistance of a metal won't be zero. It must start somewhere. But as you increase the temperature, the resistance will keep on increasing. So we go with this option here. Okay, the next one. The figure below, is in the figure below. The figure shows, the figure opposite, sorry. The figure opposite shows current carrying wires, okay? What is the value of I1? What is the value of I1? Here we are going to apply what? We are going to apply which law? Yes, Kirchhoff's first law. Kirchhoff's first law. So current in will be equal to current out. The sum of the currents entering a junction is equal to the sum of the currents leaving the junction, the same junction. So the currents entering here are, we have 4 amperes plus 5 amperes plus 6 amperes, okay? Which currents are leaving? We only have 2 currents leaving. This is the junction, by the way, they're entering this junction and then leaving. So 12 is leaving plus I1, which we don't have, is also leaving. So I don't have to write this one. We'll have it in the final answer that we'll have. Okay, so what is the sum of the currents entering the junction? If you add this, you get 15 amperes from this side. Then this side we still have 12 plus I1. So what do you add to 12 to get 15? It's 3. Or you can talk of 12 will cross to this side, it will be minus. So I1 will be 15 minus 12. So you end up with I1 being 3 amperes. So where is it? 3 amperes is here. Yeah, so from that, these two will be equal. Question number 17. The figure below shows electrons flowing through 2 wires of the same material and different radius. Same materials but different radius. Okay. If R1 is equals to 3R2, okay, R1 is here. This R1 is equals to 3R2. R1 is 3 times this other one. The radius of R1 is 3 times the radius of the second material that we have. What will be the drift speed of the electrons V2? What will be the drift speed of the electrons V2? So we have V2 here. So here we are going to apply something that we can get from even fluid flow. If you multiply the drift speed V1 with the cross-sectional area, this area, I'll call it A1, you should get V2 multiplied by A2. Yes, the cross-sectional area of this one multiplied by the drift velocity V2. Yeah, V1 multiplied by this area should be equal to V2 multiplied by the area. We can get the area because V1 now multiplied by, how do you get area? It's pi r squared in this case, but it's R1 is equals to V2, then pi r what? It's R2 squared. Yeah, these two should be equal. But now we have been told something. R1 is equals to 3R2. Yeah, R1 is equals to 3R2. So we are going to substitute where we have R1 with 3R2. So what do we have now? I'll have V1 pi. So where I have R1, I replace it with 3R2. So 3R2, and of course it's being squared, should be equal to V2 multiplied by R2 squared. Oh, we have the pi. Where am I leaving the pi? I have not dropped it. Yeah, pi R2 squared. From there, you will realize that we have some parts that can be dropped. You can drop this pi and drop this pi at this stage. Then you can square. We'll have V1. So you square all of them. So 3 squared you get 9. Then R2 squared you get R2 squared is equals to V2 then R2 squared. We had cancelled the pi. Then from here now we can drop. What can we drop here? We can drop the R2 squared. You drop this and this. We'll be left with 9V1. You start with the number is equals to V2. And I think this is what we are looking for. So V2 is equals to 9V1. So you go for this one. Yeah, you go for this one here. Okay, question number 18. The figure below shows an electric circuit with a potential circuit with a potential divider. Okay, if R2 has a resistance of 40 ohms, when the voltmeter reads 5, what is the value of resistance R1? So they're saying when this one reads 5, this voltmeter 5 volts, then R2 is 40, and this is what we want. Okay, you can go back to the formula table, you will get what we will use, but we will use this one. We will use V out is equals to R2 over R1 plus R2 then multiplied by V in. If you go to the formula table, then you will get this. But this is what I'll use. I'll start from V out over V in. It's coming from this. You divide both sides by V in. So V out over V in is equals to R2 over R1 plus R2. Do we have them? Yes, we have V out is 5 over, this is always the V in, this is the out. So V in is 12 is equals to R2. R2 is 40, and then R1 we don't have, then plus R2 which is 40. What do we do from here? You can cross multiply. So you'll have 5 multiplied by R1 plus 40 is equals to, so you also multiply 12 multiplied by 40. If you open these brackets, what do you end up with? We will have 5 R1 plus, so 5 by 40 you get 200 is equals to 12 times 40. What do you get? 12 multiplied by 40, you end up with 480. 480. So 5R1 will be equal to 200 will cross to this side, it will be minus. So 480 minus 200, you end up with 208. Yes. So from there now we can get our R1. So R1 will be, you divide both sides by 2, no, you divide both sides by 5. So you divide 5 R1 by 5 and then 280 by 5. Yes. So what is R1? So 280 you divide by 5. Not, yeah, 280 divide by 5. 280 you divide by 5. Yes, it's here. So it's coming to 56 ohms. I'm seeing it's here. Okay. Then we have this one. 2 wires A and B are made from the same metal and have equal lengths. Okay, they have the same lengths. If the resistance of wire A is 9 times greater than that of wire B, so the resistance of A, so RA, it is 9 times, so it's 9 times RB. Okay, what is the ratio of the radius of both wires? The ratio RA/RB, that is the radius, the radi. Okay, here we are going to use this. I think you have seen it somewhere. R is always given by the resistivity length over area. But area now we will use the pi r squared. So we are going to equate these two. So I'll have, for RA, the resistance will be given by the resistivity multiplied by, okay, the length over the area is pi RA squared is equals to, this side I'll have 9 multiplied by the resistance of B, which is the resistivity multiplied by the length over the area, which is pi RB squared. Okay. So remember, the lengths are the same and it is the same material. So I can drop this, 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 and this. You can also drop the pi. So look at what you are going to be left with. I'll have 1 over RA squared is equals to 9 over R squared B. But they want the ratio R to A. No, RA to RB. Yeah, RA to RB. So what do I do here? Just play around with them. I'll make sure I have RA over RB. So I'll take this to this side and then bring the 9 down. So I'll end up with 1 over 9 is equals to RA squared over RB squared. Then you get the square root, so you'll end up with RA over RB is equals to, what is the square root of 1 over 9? So you end up with 1 over 3. Therefore, the ratio RA to RB is going to be equal to 1, 2, 3. Yes. So that is this one. Yeah, that is the last part of session 3A. So next we will work on this one in session 3B. See you there. Okay.